Welcome to the how-to video for the complete communication system decibel and power analysis. Okay, here's our system. We have a 100-watt transmitter, 150 megahertz, 35 feet of RG58 coax, a 2M7X Yagi antenna. We have 20 kilometers and 100 megahertz signal through air, received by a antenna 2M4X, 50 feet of RG58AU coax, and received by our receiver here. And we're looking for coax losses, free air losses, our ERP, and our antenna gains. And then at our receiver, we're going to do dBm and microvolts. First thing we're going to do is take a look at our coax attenuation chart. And we're going to look at our RG58AU at 150 megahertz. And we come up with, at 35 feet, and it's a ratio, 2.135 dB. And our receive cable at 3.05 dB. Alright, let's take this time to look at some antenna definitions. We have an isotropic radiator. It's a theoretical antenna that radiates waves with equal intensity in all directions. Actual antenna doesn't do that. Next one would be dBd, decibels relative to a dipole. So measures the gain of antenna concerning a reference dipole antenna. A reference dipole antenna provides a fixed 2.15 dB of gain over an isotropic antenna. Dipole antennas consisting of two conductive elements are fundamental elements in RF engineering. And then we look at dBi, decibels relative to isotropic. It's a unit measurement that describes how much power an antenna transmits in a single direction when compared to an isotropic radiator, which transmits in all directions at once. Let's take a look at one of our antennas, the 2M7X, and we're going to need two values, the gain in dBi and the gain in dBd, and we're going to calculate our dBd value from subtracting 2.14 from our dBi value, and I got this formula from our other antenna, and we need to confirm that these antenna, the frequency range matches our problem, and it does. Okay, here's our second antenna, the 2M4X. Its gain is 9.6 dBi, and we're going to subtract the 2.14 from dBi to get our dBd. Okay, in order to calculate our free space path loss, we need to go to this link here and utilize their calculator. So here we have our distance of 20 kilometers, 150 megahertz, our transmitting antenna gain, and our receiving antenna gain, and we push calculate, and our free space loss is 80.1 dB. The next thing we need to find is our effective radiated power, or ERP, and we're going to put it in this calculator that we found at this website. So we have 100 watts, 2 dB loss in our cable, and our antenna gain is 10. And we'll go ahead and hit the calculate button, and we're going to come up with 58 dBm and 631 watts. Okay, we have the formula here, and we have 100 watts based on 1 milliwatt. So I'm going to go ahead and use a calculator. So we're going to do on, clear, log 100 divided by 1 second EE minus 3, don't use the minus sign. Let's close the parentheses, equals times 10 equals, and that should give us 50 dBm. Okay, let's find our transmitter dB input. And okay, so let's calculate our transmitter dBm input. Subtracted. So we're going to go through and 50 dBm at the amplifier. Take a look and add everything up. Our ERP is plus 58 dBm from our amplifier. From our cable attenuation coming out of our amplifier minus 2.1 dB, which we found from our other ERP is online calculator. 1 dB. Our antenna gain is plus free air loss is minus 80.1 dB. Our antenna gain going into our receiver, so we come up with a total of 34, and our cable attenuation going into our receivers minus 3. And we go through and utilize our formula. It comes out to 11.87 microvolts. And here's our input into our calculator in order to find that. Here I have a complete diagram of all of our values. So we start here with our 100 watt, 150 megahertz transmitter. Our dBm output is 50 dBm. We have a 2.1 dB coax loss. Go through our 7X Yagi antenna. So our antenna gain is 6.3 dBi. Our ERP is 631 watts and 58 dBm. We have a free air loss of minus 80.1 dB. And we go into our 2M4X antenna. Our antenna gain is 9.6 dBi. Our coax loss is 3.0 dB. And at our our receiver, we have 34.5 dB and 11.87 microvolts.